Hello, and thank you for signing up for this webinar on geothermal power plant compliance and operational safety. Now, before we start, here's a quick introduction of our speaker today. We have with us Mr. David Bordeaux, who is responsible for strategic account management at the corporate level in TÜV Süd. His focus is on advisory, testing, inspection and certification solutions for the power and energy, as well as chemical and process industries. He's been with us for the past 10 years, holding several sales and business development senior management positions. Before moving on to the power and chemical and process industries, he had 10 years of experience in the automotive industry, starting with the development teams for safety restraint systems for car manufacturers before moving on to various program management positions for reputable car manufacturers. With that, I will now hand you over to David.
Hello, dear participants, ladies and gentlemen. It's my great pleasure to welcome you for this first geothermal power webinar. This webinar will focus on geothermal power plant certification and, in the second part, on mandatory regular inspections during operation. Before I enter into the details of my presentations, I would like to provide you with a brief overview of who we are. This slide provides you with a quick overview of TÜV Süd in numbers. TÜV Süd is a one-stop technical solution provider powered by 150 years, more than 150 years of experience in the safety, quality and sustainable business. We have more than 1,000 locations worldwide, a lot of labs, technical offices with experts, and we have more than 24,000 employees all over the world. Half of them are not located in Europe, in Germany, but outside of Europe, in all the countries of the world. We generate 2.4 billion euros revenue every year, or last year at least, and we are a 100% independent and impartial company because we are a notified body, not always acting as a notified body, but we are a notified body acting for the authorities. Our technical expertise is covering testing and product certification for compliance with directives and international recognized standards. We inspect processes, production facilities, buildings and infrastructure. We audit and certify systems. Typically, you all know the ISO system, management system, quality system like ISO 9001, 18001, 14001, 50001, environmental testing. We provide knowledge and advisory services on quality, safety, risk and environmental protection. And we train with our academy. We train people and provide certified qualification trainings. These are the quick overview of our services, and we deliver these services across industry sectors like chemical and process industry, downstream, midstream mainly, consumer products and retail, energy sector, nuclear, renewable and conventional energy generation, but also distribution, networks and grids. In the sector of healthcare and medical devices, manufacturing companies, mobility, vehicles, we inspect vehicles, and for the real estate and infrastructure industry sector. This is our presence, our footprint in the world, in the countries where we have experts. Let me now step in to the main subject and topic of today, geothermal power. First, I will start with a short introduction about the technology and about our experience in the south of Germany. There are principally three kinds of geothermal power plants: binary cycle, dry steam, and flash steam. The selection of the right technology depends on the geothermal characteristics, on the geology, on the characteristics that you will find locally in your region, namely the temperature of the water and the state of the water. In Europe, and especially in south of Germany, in Bavaria, where we are located, the temperature of thermal water at about 3,500 to 5,500 meters depth is about 95 to 140 degrees Celsius maximum. And that's why geothermal energy is used for district heating mainly. But more and more in the past years, power utility providers decided to use geothermal energy also to generate power. And the technology used is binary cycle. Most of the time, the so-called organic ranking cycle, ORC, organic ranking cycle plant technology. Binary cycle geothermal power generation plants differ from dry steam and flash steam in that the water of the brine, of the hot brine, of the geothermal water never comes in contact with the turbine. There is a secondary loop, hence called binary loop, with an organic working fluid, with a much lower boiling point than water. And this passes through a heat exchanger. Heat from the geothermal brine will be taken and causes the working fluid to evaporate. The working fluid steam then drives the turbine and generates power. So we have two fluid loops. The first one, the hot brine, the geothermal water, and the second one, which is a completely closed loop, the one with the ORC, with the organic fluid, the working fluid. The working fluid closed loop has different states, temperatures and pressures: liquid, vapor, high temperature, low temperature, high pressure, low pressure. And thanks to the cycles of vaporization and condensation, the production of and the generation of power through the turbines can take place. On the left side of this slide, you can see a short excerpt of our project references in the past years in south of Germany, in Bavaria. For example, Kirchhofer, and what you can see is that the main projects have been equipped with an organic ranking cycle power generation plant. Later on, I will take the example of Dionach and Kirchhofer, two small municipalities which are located 20 kilometers southeast of Munich. When talking about geothermal power plants, certification and about safety inspections, you have to consider the whole life cycle of a plant, of a project. First starting with the planning and design, then going through the manufacturing, and after the declaration of conformity and after the commissioning of the plant, the operator takes over and enters the operation phase. Here are some examples of the questions, of the critical challenges and questions that may happen and may be asked by the manufacturer or by the stakeholders. First of all, during the planning and design, a question, typical critical question could be which regulation or standard will be applicable to the construction? Who has the entire responsibility of the manufacturing of the plant? Who is the EPC or the packager or the main contractor for the plant? Have all hazards been considered systematically? Which permits and authorization do I need from the mining law, from the construction law, regarding emissions, and so on and so forth. When it comes to manufacturing, then the manufacturer has to make sure that the delivered quality fulfills the design requirements which have been set up before during the planning and design phase. A critical question at that stage are, for example, did the vendors implement the requested design specification in their manufacturing shop? Is the delivered quality the right one? And do they have evidence of manufacturing quality validation? If everything has been done in the right way, then the notified body will issue a declaration of conformity, and there will be a kind of commissioning of the plant and a transfer of responsibility from manufacturer to the operator. The operator takes over the plant, and basically its main target is to maximize the performance of the plant, increase output and availability, reduce breakdowns, optimize operational and maintenance costs. But, however, the operator has duties. He has to meet his obligation in terms of safety. He has to demonstrate that he operates the geothermal power plant in a safe manner for the workers and for the environment. So as you see in a summary, in a nutshell, we can say we have two mandatory packages. The first one during planning, design and manufacturing, the plant certification, in the responsibility of the main contractor, the EPC or the packager. And the second package of mandatory inspections, which is the safety inspection during the operations. This is the responsibility of the operator. Let me now come to the first package, which I presented earlier, namely the plant certification of a geothermal power plant. We at TÜV we have developed a guideline for geothermal plant certification, a practical guideline to cover all the aspects of the certification. What you see here on this slide, and the first thing that you see is that this is a right project. The certification of a plant is a right project and has to be considered as a project. Means it has to start in the early concept phase. From that perspective, the geothermal power plant manufacturer has to face many challenges. He has to make sure he starts in the early phase to consider the mandatory requirements. Then during manufacturing, he has to make sure that the quality delivered is the right one, and in order to be able to make a right handover and transfer to the operator. You see on the right side of the slide that there are many technical requirements and standards, typically that have to be taken into consideration. Pressure, equipment, explosion protection, water protection, emission, functional safety, and other standards like lightning protection, fire protection, EMC, noise. I have put them into three blocks of requirements. First, the work packages covered by the Pressure Equipment Directive, pressure equipment and functional safety. Then work packages which are not covered by the Pressure Equipment Directive, explosion, water protection, emissions. In some of the countries, groundwater protection will not be mandatory. In some other countries, it will be mandatory. And there are other requirements like lightning protection, fire safety, EMC and noise, as I mentioned before. Today, I will focus on the green package, pressure equipment and functional safety, because obviously this is the package with the most demanding and most severe requirements, which need to be taken into account, into consideration from the early beginning of the project. Our approach at TÜV is to settle a team of experts. We have a main responsible project manager, and he will involve the experts when requested by the project schedule. The certification manager handles all the activities along the compliance project, together with the manufacturer on the one hand, but also with the authorities on the other hand, in order to make all the certification applications or to ask for clarification when needed. So let's go now to the description of the certification process for pressure equipment as it works in Europe. So again, we focus now on the pressure equipment. It's not the only one request and requirement, mandatory requirement for geothermal power plant certification, but as I told before, this is the more demanding, and that's why I think it's the one we should need to focus on today. Pressure equipment of the whole assembly. A geothermal power plant is considered as a whole assembly in the perspective of the Pressure Equipment Directive. In Europe, the code is the Pressure Equipment Directive. In other countries, pressure equipment may be developed according to different codes, like ESNE, Earthing Code, for example. In principle, the two codes, the European Pressure Equipment Directive and the ESNE codes are very similar, but I will focus on the Pressure Equipment Directive today. By the way, TÜV we are also a notified body for ESNE, not only for Pressure Equipment Directive in Europe. So let's have a closer look at the PED certification principles. Again, a whole geothermal plant is considered as an assembly. And before the whole plant can be certified, we first need to have a look at single pressure vessels. each piece of pressure vessel, of pressure equipment, has to be certified according to the European Pressure Equipment Directive. It means we need, as a notified body, to have a look at the design, to approve the design. This is mainly an office work based on documentation. And we need to check the manufacturing shop quality at the vendors. The main critical challenge here and question here is to check the quality and to make sure that all the vendors, all the single manufacturers of pressure equipment are aware about their duties, about their specification and requirements, and about the code they need to develop the pressure vessel in accordance to. The second part of the conformity to the Pressure Equipment Directive for the whole unit is a mechanical interaction within the assembly. Again, there will be a design approval made on the documentation in the office, and there will be, during installation, an on-site final assessment of the notified body. And finally, last but not least, the protection system, the functional safety of the whole assembly has to be checked. What does it mean, the protection system? Basically, the protection system of the unit includes all safety features that prevent hazards to happen. These are devices designed to protect pressure equipment against pressure exceeding the allowable pressure. There are two kinds, in principle, there are two kinds of safety accessories. The direct acting safety accessories like safety valves, bursting discs, and there are the PLC control systems, so instrumentation and control system technology. When all these three steps are done according to the European Pressure Equipment Directive, then the notified body, QSUD, will be able to assess a final report for the assembly and to issue a certificate of conformity for the unit. But let's have a closer look to each of these three steps described on the previous page, and let's answer the first question: how to certify a single pressure equipment in Europe? First of all, what is a pressure equipment indeed, and what kind of pressure equipment will exist? A typical pressure vessel is a housing designed and built to contain a fluid in a different state, at a different temperature, different composition, aggressivity, corrosion, and these kind of things. Piping systems are also pressure equipment in the perspective of the Pressure Equipment Directive, means they are intended to the transport of fluids. Pressure accessories, the devices with operational function and having pressure-bearing houses, are also pressure equipment. Safety accessories as well, and the whole assembly means an assembly of many single pressure equipment pieces is also a pressure equipment in the wording of the Pressure Equipment Directive. First of all, in order to certify a pressure equipment, the manufacturer will have to categorize this pressure equipment. And the categorization of the pressure equipment depends on potential of hazards. A greater category means a greater potential of hazard, and thus higher requirements for the quality assessment and verification, means for the certification. The assessment procedures describes the activities that the manufacturer shall do to verify that the requirements are all fulfilled. And that's what you can see here on the right side of my page. You see the four categories of the Pressure Equipment Directive, 1, 2, 3, and 4. Category 4 is the highest one, and you see on the right side that if my pressure equipment is categorized into the category 4, there are 4 modules, 4 assessment procedures available for the manufacturer in order to assess the conformity of this pressure equipment. The potential of hazard from which the category depends are defined based on the technical physical characteristics of the pressure equipment. Mainly this is the pressure. Higher pressure means higher risk. The temperature, higher temperature means higher risk and hazard potential. The volume of the pressure vessel, a bigger pressure vessel has more risks than a smaller one. The fluid group Do I have a dangerous hazardous fluid, explosive fluid inside or not? And do I have a gas or a liquid? You see on the right side that the most frequent category and the most frequent module assessment procedure which is used for geothermal power plants is the module G. It's the so-called conformity based on unit verification. This module G ensures the highest possible degree of product safety and also the highest possible flexibility, because every geothermal plant is unique, so to say. It's not a type which can be duplicated several times, 10 times, 15 times at every location, because it's a lot depending on the characteristic of the geothermal water and of the output of the plant that every operator wants to achieve. Let's make a live demo with an example and try to categorize the pressure equipment together. We will take a preheater as an example in the organic ranking cycle loop. I will switch to our software. You see here on the right, on the left side of the page, an example or a screenshot of this software that we use. Let me make a demo with you now. We at Tulsud, we have developed a pressure equipment software, which is called PED for Pressure Equipment Directive Professional 6. As you see here, this software offers a lot of features like information guidelines about the directive, information about the European Declaration of Conformity, but also the module here, categorization of pressure equipment. How does it work? Let's take a preheater in the ORC loop. The manufacturer is called manufacturer Lambda. This preheater has a maximum allowable pressure of 30.5 bars. The volume of this preheater is 3,700 liters. It's a pressure vessel, and the medium which is in this pressure vessel is liquid or gaseous, is gaseous, with a pressure greater than 0.5 bars. The fluid is a dangerous fluid because it's an explosive fluid. It's a refrigerant or the organic fluid which is inside. When I've done all of this, the system will calculate for me the category in which the pressure equipment has to be categorized. And you see here, category 4. It's a vessel with a fluid which is gaseous, fluid group 1, dangerous, and you see on the right side the characteristics of my pressure vessel. So it's a category 4 pressure equipment, and I need to follow the module G or one of the other 3 modules which are proposed, but as I explained before, it will be the module G, assessment procedure. Let's come back now to my presentation. Just a second. Now it should be better for that.
Much better,
okay.
David.
Okay, good. So we have now categorized the hazards, defined the hazard of the pressure vessel equipment. We have the category, and we know which assessment procedure, namely module G, we will choose to validate and to certify this pressure equipment. We will check the design on the one hand, and we check the delivered quality of the manufacturing on the other hand. The manufacturing and construction quality in Europe typically will be checked according to the standard EN 13445. Each individual vessel shall be inspected during construction and after completion. Inspections shall be made to ensure that design, materials, and manufacturing comply with the requirements of the standard. What do we check? First of all, we make a test report including welding procedure specification, welders certificates, material certificates. We do non-destructive testing of welded joints, and we make a final pressure test. Belonging to all of this, technical requirements and documentation is also a general description of the pressure vessel, a drawing, operating instructions, and results of calculation and examinations. The third part of the certification assessment procedure is the assessment of the protection system, as I explained before. As defined in the IEC standards, the IEC standard 61508, for example, there are 4 safety integrity levels, the so-called SIL levels. A greater level, SIL 4, means greater risk, safety hazard potential. When the safety level has been defined, the manufacturers can design and implement accordingly the necessary safety features in the plant. And these safety features are of 2 types. There are the direct active devices like pressure relief systems, safety valves, or rupture disc protectors. And you have the so-called SRMCR, safety-related measurement, control and regulation, which are limiting devices, PLC systems that trigger correcting devices or cause a shutdown of the plant before happening of the hazards in the plant. This has to be also assessed by a notified body. When done, the pressure vessel and all the unit, the whole unit, can be certified according to the Pressure Equipment Directive. Let's take an example here to make it more visible. Let's assume we have a geothermal power plant. The manufacturer is called manufacturer A, and at the end he wants to get his certificate of conformity in order to commission the plant. There are many sub-assemblies within the geothermal power plant, but 2 main assemblies, sub-assemblies, are the sub-assembly 1 for the thermal water circuit and the sub-assembly 2 for the organic cranking cycle with the working fluid. Within the two assemblies, let's take the sub-assembly 2, ORC loop, there is many single pressure equipment. All of these have been certified according to the Pressure Equipment Directive, as I just explained before. The preheater, we have taken this example, has been certified according to Module G, because it's a Category 4 equipment. And the same has been done for the evaporator. Maybe it's another vendor, another manufacturer, probably. The piping system, high pressure side, have been also categorized and certified and assessed and certified by a notified body at the vendor, and so on and so forth. Then the sub-assembly 2, the whole loop, is also a pressure equipment in the perspective of the Pressure Equipment Directive, and will be as well certified according to Module G. The same for the sub-assembly 1, for the thermal water circuit, hot prime. And then, if you assemble all the sub-assemblies together and look after all the interactions and the protection system of the plant, you will be able, with the help of a notified body, to get the certification, the final certification of the whole geothermal power plant as an assembly unit. At the end, you will have a dossier, a kind of technical dossier with all the documentation. Belonging to this documentation, the operating instructions, very important, for a right transfer of responsibility from the manufacturer to the operator. The notified body can issue a declaration of conformity. And at the end, there will be a CE marking, if it's in Europe, of the pressure equipment of the whole geothermal power plant. You're done. You have it. So, this was, in a quick overview, the process, how it works to certify CE conformity of a geothermal power plant, with the example of the pressure equipment and the functional protection system of the plant. In the second part, I would like to now come on to the second package, which I explained before in my introduction, namely the safety inspections to the operator. Now the EPC, the packager, has made the transfer of the plant to the operator. The plant has been commissioned or will be commissioned soon. There is a declaration of conformity. Everything is green. In the world, and in Germany as well, in Europe as well, there are some safety regulations during operations. In Germany, this is the so-called Betriebssicherheitsverordnung. It's the operational safety ordinance. And a system is safe if it observes the system integrity, the occupational health and safety, third-party protection, protection to third parties, and environmental protection. Regarding the use of work equipment, this operational safety ordinance is applicable in Germany, as I told before. The content of the operating regulations is inspections before commissioning and periodic inspections. They can be regulated by each member state in Europe, and very probably in your respective country there will be for sure a very similar operational safety regulation that the operator needs to fulfill and to take into consideration. The only differences may lie in the scope of the regular inspection, in the inspection intervals, periodicity, and in the requested inspector qualification. In some countries, an independent authorized inspection agency like TÜV is mandatory to make all the inspections, the periodical inspection. In some other countries, depending on the scope, operator can have its own qualified inspectors or contract an external inspector. I will focus on the paragraph 15 and 16 of the chapter 3 of the German Operational Safety Ordinance, because these two chapters cover the inspection before commissioning and the periodical inspections. In Germany, in Europe, in order to translate in a practical way the requirements of the paragraph 15 and 16, there are so-called technical rules which can be used, which have to be used. Technical rules on operational safety. This technical rule 1201, called Inspection of Work Equipment and Systems Requiring Monitoring, is the technical rule which is used in Germany in order to define the scope of the specification. This leads to a definition of the inspection type. The extent means the scope of the inspection, the periodicity of the inspection, and this defines also the person skills who has to do the inspection. All of this is described in an inspection and test plan. Let's give some more details about the commissioning, the so-called pre-service inspection, paragraph 15. This is the test prior to commissioning, and this is the test which determines whether the pressure system is in proper condition for the intended mode of operation. The notified body, the inspection agency like TÜV, checks on site whether all the necessary technical documents are available, for instance, the manual operating instructions. The system is properly installed and in safe condition. If all the safety measures are suitable and effective, and checks also the deadline for the next periodic inspection. I want to give you a key message here. You have understood before in my first part of the presentation, how we certify a geothermal power plant, a generation unit, like an ORC power plant. You have seen that we use most of the time the module G assessment as an assembly. And there is a great benefit in terms of time and cost to do this, because then when it comes to pre-service inspection and commissioning tests, it will be time and cost saving for the operator and for the manufacturer. There is only one contact for one manufacturer, one unit assembly which has been certified. There is a structured inspection method which can be defined, There are clear responsibilities, not diluted responsibility between many manufacturers, only one EPC packager with one operator, with one notified body, less interfaces. Let's come now to the Article 16 of the ordinance, of the safety ordinance in Germany. The paragraph 16 defines the so-called periodical inspections. Again, the technical rule 1201 is the one which is used in order to translate in practical way the requirements which have to be taken into account. There are three types of inspections, of regular inspections. First of all, the external inspections, which are the assessment of the external condition of the pressure equipment. We check if there are vibrations, correct installation of the fundament, leaks, maybe not normal discoloration, corrosion from outside, or solid deposits. We check the existence and the condition and the safety of the safety relevant equipment, the protection system. Besides the external inspection of the condition of the pressure equipment, there are the internal inspections, which is the testing of the pressure bearing walls. We check the internal condition of the pressure equipment with accurate non-destructive testing in case of failure or vulnerability. And at the end, we have also to do a strength test according to this paragraph 16 of the safety ordinance. Strength tests are usually inspection of cracks, of impermissible deformation and leaks through a static pressure test with water or another medium. So you can imagine sometimes these tests can be difficult to conduct because you need sometimes to empty the tanks or the pressure vessel to shut down the plant. So sometimes it's time consuming and not easy to do. All these tests have to be done in Germany with a notified body, with an authorized, approved inspection agency like TÜV. They are all described in the so-called inspection and test plan. Here you see an example with courtesy of TÜV Bordeaux. We are allowed to use it. We made this with them. You see that the manufacturer first has certified his geothermal power plant. I told you before, I will take the example of Bordeaux, which is this small municipality southeast of Munich. This is a geothermal ORC with high temperature and low temperature cycle. What is interesting to see here is that the pressure equipment system has been split in 6 subsystems, A, B, C, D, E, and F. Low pressure section, high temperature, low pressure, low temperature, and so on and so forth. Here is an extract or an excerpt of the inspection plan proposed by the manufacturer. And you see here, for example, the system C, the high pressure section, high temperature circuit. There is a list of all the single pressure equipment and information about the category according to the Pressure Equipment Directive, category 4, as I've shown you before. And then the assessment procedure, the module which has been chosen and taken in order to certify and to assess the conformity. It was the module G, in that case, for the preheater. Low, high temperature and high temperature cycle. And you find here in this document the main physical characteristics of this preheater or evaporator, microfilter, and so on and so forth. What is interesting to see here is the check interval times to find again the external inspection, the internal inspection, and the strength test, as I mentioned before. And you see, internal inspection has to be done every 5 years. Strength inspection every 10 years, with some remarks. We at TÜV with the manufacturer, not with the manufacturer, sorry, with the operator, we make a detailed inspection plan with the scope and the methodology. Means Then we meet with the operator of the plant with the recommendations of the manufacturer, and we define a detailed inspection scope and methodology. We say, for example, the collecting tank, the internal inspection method, we will use a visual check. Or we will use an acoustic emission testing, NDT testing. I will come to this in the last slide. We are almost at the end of my presentation. You see, we need to define based on the recommendations of the manufacturer and based on a joint work with the operator, we define every single inspection, the periodicity, the scope, and the methodology for the inspection, and we put that in a final inspection and test plan. Why acoustic emission testing? This is a picture of our Tube light truck for acoustic emission testing on the location of a geothermal power plant in Kirchstocker, which is also a small municipality southeast from Munich. And you see here the air cooler on the top right of the picture. You see a tank, which is the collector tank for the working fluid. And we are here with our light truck doing and starting an acoustic emission test. Why? It's allowed by the regulation safety ordinance to use an acoustic test and not to do a pressure test if it's not possible or not appropriate. It's allowed to use an equivalent non-destructive testing methodology. And the acoustic emission technology is very accurate for this and brings a lot of benefits, I would say. First of all, the benefits, number one is that you have a comprehensive, whole evaluation of the pressure equipment completely, and that you can localize active failures and cracks during the operation without having to empty the tank and to shut down the plant. It's a real-time monitoring assessment, so to say. So you can imagine that it's a very great benefit in terms of time and cost for the inspection and at the end for the operator. There is no intensive preparation work, shorter inspection time and less cost. This is an example of an innovative NDT testing which we use and which we really implement within the inspection and test plan for a geothermal power plant. I'm now at the end of my presentation.
So that's all that we have for you today. Thanks to all of the participants, and have a good rest of the day ahead.